Hi, this is week 8, an online class, and today we are going to talk about multiple baseline designs. So, multiple baseline designs really are A-B designs that are replicated 2 or more times. It's the most widely used design in ABA, and I think primarily that's because reversal designs or withdrawal designs that we talked about last time are certainly the simplest and show functional relationships in the most straightforward way. But because of the disadvantages we talked about and the problems of reversibility and the ethical problems of reversing the problems, multiple baseline designs, because as you'll see or you already know from reading Richmond's book, have various adaptations and types, and so they can be quite useful in terms of demonstrating functional relationships. So really, when you look at this, it appears visually as a series, a multiple baseline appears visually as a series of A-B designs stacked on top of each other. So in this case, this is a multiple baseline across behaviors. So these aren't marked, but let's say these are academic behaviors. This might be math, this could be spelling, this could be reading, and this is the level that the individual, this is one individual, is at before intervention. Here is the intervention, which is the same across all three. And wow, quick, big increases in the intervention for the first A-B replication. But then the key is, and we'll talk more about this, when the intervention was implemented on the first behavior, there was a change, but the baseline remains the same in the second and the third behaviors, and you don't get an increase until you introduce the multiple baseline. So that's really how you demonstrate your functional relationship, is that and that's really the mechanism that's used in any of these multiple baselines, whether they be across behaviors, as in this case, across subjects, these could be individuals, or across situations or locations, settings. This could be in classroom 1, classroom 2, and classroom 3, for example. You're demonstrating control and demonstrating your functional relationship, because when and only when you implement the treatment do you get a change in each of the behaviors, settings, or individuals that you're manipulating. I hope that's clear, but I can't see your faces to determine if it is. So you use a multiple baseline design, well, when one or more people, behaviors, or settings is in need of treatment, but primarily it's done when a withdrawal or a reversal design just can't be done because of irreversibility, or you don't want to do it because of ethical problems that we talked about 2 weeks ago. So, as I mentioned, there's 3 basic forms. You can do this across behaviors, across subjects, or across settings. The goal is in order to demonstrate a functional relationship between the dependent variable, that is your intervention, and the independent variable, that is your target behavior, by replicating the treatment effects across either the behaviors, the subjects, or the setting. So multiple baseline across subjects, the independent variable is applied to similar behaviors of different subjects within the same setting. multiple baseline across behaviors. The independent variable is applied to several behaviors of the same individual within the same setting, and multiple baseline across settings. The independent variable is applied to the same behavior of the same individual across different settings. So here's an example of a multiple baseline across settings: classroom, playroom, outdoor. So this is decreasing mouthing, and again, you're demonstrating control because it's occurring at a high rate in this first AB in the classroom. When you introduce the treatment, it shoots way down. However, you're demonstrating control because it didn't just come down immediately when you introduce the treatment in the other two settings. This is important because it controls for those confounding variables. Whoa. Remember, when we talked about the withdrawal design, the problem with, or the AB design, the problem with that is there's a lot of other things that could have happened. So, for example, there's a lot of other things that could have happened after this baseline that resulted in a decrease. It could have been the intervention, or it could have been that there was a new teacher in the classroom, or it could have been that the student had to start taking the bus in the morning instead of getting dropped off by mom. Or it could have been that allergy season started. However, you decrease the likelihood of those, just like you do with the reversal design when you reverse back and forth, because it's unlikely that those same things were the difference when you implement these treatments sequentially across different settings in this case. So it's unlikely that something weird happened other than the treatment here and here and here. Now, if these baselines in the other two conditions drop down, well, then you would not have demonstrated control. Again, I hope that's clear. If it's not, send me a little note on the, send me an email or send me something in the discussion forum, and we'll talk about it some more when I see you next week. All right, here's an example of the one we just looked at, a multiple baseline across subjects. This one is increasing it. Same thing. So it's same individual, different behaviors, as I said, maybe spelling, reading, and arithmetic. And again, you're demonstrating control, you're demonstrating a functional relationship. When you put the intervention in, you get a change. But you don't get a change until the intervention is in. And that's the key. So it's this part staying low after the intervention is in the other areas, and it's this part in showing a change once the intervention is in, that are both required in order to demonstrate control with a functional, with a multiple baseline. And finally, this is a multiple baseline across subjects. Actually, these are dyads, the teacher and student. It's complicated, but I think we'll read this study later. And so, again, same thing, multiple baseline across. Now, this one is individuals. So it's important to demonstrate that you don't get a change until you introduce the intervention here. Okay. So, basically, the general mechanics which I just described, this is it in words if you do better with words. I do better with pictures, but we'll have them both. So you obtain baseline performance across the dependent variables, implement the intervention for the first dependent variable while maintaining baseline conditions for the independent variable. This is a clearer example. So you maintain baseline in the second and third while you're implementing treatment here. And when stability is achieved for the first dependent variable, target behavior, implement intervention for the second while maintaining baseline for the third, and when stability is achieved for the second, implement intervention for the third. Okay? Hopefully that is crystal clear. So you implement treatment here, show an improvement here, but demonstrate that no change in the untreated baselines. Implement treatment here, demonstrate a change after treatment here, but also, just as importantly, demonstrate no change here until you implement baseline here. So you're replicating it. The probability that there is a confounding variable, that is, that there's something else other than your treatment that has resulted in this change, is highly unlikely. And obviously, the more times you do this, the more unlikely it is. Same logic as with the reversal or withdrawal designs that we talked about last time. The more times you do it, in ABA is a pretty good demonstration. And ABABA is a better demonstration. So this, you can demonstrate it across two behaviors. That's a pretty good demonstration. 3, it's even more unlikely that there's some confounding. 4, well, heck, it's really unlikely that some other confounding variable could have occurred. Okay. All right. So there's some considerations when you're doing any kind of multiple baseline designs. One is that the real challenge here is you have to find behaviors that are independent. That's the biggest issue with a multiple baseline design. So in this case, multiple baseline across behaviors, you need to find 3 behaviors, math, reading, spelling, that are independent. That is, if you get better in math, you're not going to get better in reading. And if you get better in reading, you're not going to get better in spelling. And because obviously, if they were all part of the same response class, then you've got a huge problem in that they're going to change when this one gets better, this one's going to start to get better, and therefore you're not going to be able to demonstrate a functional relationship. So you need, and this is the challenge with these, you need to have behaviors that are independent of each other, but they also have to be sensitive to the same treatment. So it's kind of ironic. You need to have independent behaviors, but they need to all be responsive to the same treatment in order for a multiple baseline to work. Hope that's clear. The other is that, yeah, that's what I just said. So the logic we've gone over, prediction, verification, replication that we've talked about. Your book spends a lot of time talking about this. I think it's pretty straightforward. Obviously, just like the withdrawal design, the prediction, verification, and replication is pretty straightforward. The prediction is that the behavior is going to stay the same. You verify that the behavior changes when the baseline stays the same in the untreated conditions, but only changes in the treated one. And the replication is each time you do that. So you do that across 2 behaviors, you replicate it at once. Do that across 3 behaviors, you replicate it twice, etc., etc. So how many different target behaviors, dependent variables, do we need to have? Well, just like with the ABA design, there really isn't a rule. An ABA could be sufficient. A BAB could be sufficient under certain conditions. However, it gets better you control for more, it becomes more powerful. We talked about the strength. It becomes a stronger design the more times you do it. Bear, Wolf, and Risley, in their classic 1968 article about what is applied behavior analysis, well, they actually defined applied behavior analysis. Said, well, it's up to consumers to decide, how sure do you want to be? Obviously, if it's going to be an intense kind of intervention, something that's going to be really expensive to put into place, take a lot of time and effort, there's going to be some ethical issues. Well, you want to really make sure, so maybe you're going to want to demonstrate it. You're going to want a more powerful design. Cooper says that a multiple baseline design with only 2 dependent variables is a complete design, but 3 or 4 provide an almost completely convincing demonstration of the experimental effects. So that's what we're saying. The more times you do it, the stronger it is. Sometimes you're only going to be able to do an A-B, and we know you really aren't demonstrating a functional relationship at all. But so it's back to the when we first started talking about this, it's a question of strength, and it's stronger the more DVs that you're actually manipulating. So some of the practical considerations and conventions are that typically you're going to intervene on the most stable baseline first, and that's another challenge with multiple baseline designs. They can take a long time because these data I'm showing you, well, some of them are real, and those are harder, but some of them are made up data, so it's easy. But to get stable baselines, when you're doing a multiple baseline, say across 3 different individuals, to keep those baselines stable, you have to run them out for multiple periods of time. It's important to try to vary the lengths of the baselines. Wow, that can take a long time. That can be a lot of effort. So basically, the advantages of the multiple baseline design is that you don't have to do a withdrawal. So if you can't do a withdrawal, as we talked about with the withdrawal or reversal designs, either because of the reversibility of the behavior, or because of the ethical issues, you don't have to worry about that. So this one, you could look at 3 different behaviors that represent learning, for example, because you're not going to have to reverse it, and you don't have the ethical problems of reversing it. It's easy to conceptualize. It really is. I don't want to make this more complicated than it is. It's pretty straightforward. Teachers seem to like this because it makes sense to them, even more than a reversal. Reversals, a lot of people have problems with reversals. They think, well, why? Wow, you're going to bring it back? That's a bad thing. But the logic behind a multiple baseline design, I find parents, teachers, they get it. They get the logic of why you'd want to do this. And finally, another advantage is the generalization effects are demonstrated within the design. So you are showing how this is generalizing. If you're doing a multiple baseline across individuals, you're showing how it's generalizing across individuals, or across various academic behaviors, or across different settings, home, classroom, and on the school bus. So you are demonstrating naturally generalization, which is important. Disadvantages. Well, it's hard. It's simple conceptually, but practically it could be hard. Finding the right kinds of behaviors. That is, behaviors that are going to be functionally independent of each other. So when you manipulate one, that you don't get a change in the other, and at the same time are sensitive to the same intervention, are hard to find. Now, your book also talks about, Richard spends some time talking about how it's, less powerful than an ABAB design. Well, yeah, boy, an ABAB design is just so straightforward. It is very powerful, but if you demonstrate a good multiple baseline, it's demonstrating control. It is very powerful. So I don't know. We're talking about the differences between a Maserati and a Ferrari. They're both powerful, but I do think a real disadvantage is that the multiple baseline design requires significant resources. It's a lot harder to do than a reversal design because you have to get stable responding across those baselines. And if you're doing 3 of them, boy, it's a lot of resources. Keep in touch with that. You got 3 different people, or you got the same individual who's in 3 different settings, and you got to, check the data in all 3 of those. So it's also very time consuming. So, here's real data, and it's, you can see some of this one, it was hard to get stability. It was sort of, the stability is up and down, but we had to run this one out for quite a while. And, this one started going up even before the intervention, which isn't a good thing. But, we were measuring 2 things, and that's the downside. You could be running these forever. Here's more real data. And the other thing about real data that I should probably point out when you're doing this is, and we need to spend some time talking about this, is typically designs, you can combine designs. We're talking about some single subject designs have advantages and disadvantages over others, and that's all true. But you can combine designs. Here, there's a ABA and then a multiple baseline across settings, in the classroom, and analog, that's in a laboratory kind of setting. So this was in a small room with just one person, an analog situation, versus in the classroom. But look how long you had to run this out, because trying to get stability on real behavior, this was on hair pulling, is really difficult to do. All right, so there's also another advantage, really, of multiple baseline designs is there's a lot of adaptations and a lot of things. Once you understand these designs, I think then you can really go with them. You just need to understand the issues, and then of how to demonstrate functional control, and then there's really a limitless number of adaptations. Sometimes I think people get stuck on just trying to sort of memorize the mechanisms. I mean, it's important to understand them, but you just have to understand how they work. You're trying to demonstrate control, and you'll have a lot more opportunities to do that if you keep an open mind and not try to just force it into a traditional multiple baseline design. Sometimes it might be a combination or a hybrid of designs that you're going to use. But so here's some adaptations to multiple baseline designs. The multiple probe, this is used to reduce the collection of data and reduce resources. So your book talks about this. Here's a multiple baseline across settings: Stephen's class, Robert's class, Michael's class. And instead of collecting the data every day, which is time consuming, here they're just probing it to demonstrate, oh yeah, look, there is no change when we introduce that. So that's kind of a cool way, in a way that you might see people using multiple baseline designs in a more functional way. Oh, excuse me. And then there's the delayed multiple baseline design, which means that the baselines are not necessarily measured simultaneously. Some people have problems with this, but I've done some variations of these, a lot of these actually, where again, you're not necessarily running it out. You're just demonstrating that before the baseline is high in all three of these conditions. And these may not be all run at the same time. So that's it for multiple baseline. As usual, if you have questions, please either put them in the discussion forum if you think they're questions that other people might have, or bring them up next week because we'll have a face-to-face class next week. Or email me if you prefer. But between the book and talking about this, hopefully you've got a good sense of what a multiple baseline design is. Next week, so for this week, read Richard's chapter 9, which is on multiple baseline designs. And then next week, we'll be back to a face-to-face class. That'll be Thursday, October 29th. And you guys will be presenting. You've already been assigned your readings, but please read all three so we can have some spirited discussions after you're presenting. But you guys are all scheduled to present next week. So have a good week, and I will see you on Thursday, October 29th.